Confidence intervals structures are all the same. We have a statistic and then plus or minus a specific number of standard deviations for that statistic. Well, that specific number is called a critical value. It's a z-score for proportions. It's a t-score for means. And this is the standard deviation for the sampling distribution of that statistic. Together, these two components make what's called the margin of error. And we can work backwards from a confidence interval to get information about the statistic or the margin of error or the level of confidence. So in example 3, let's say we have a confidence interval for the real proportion of male seniors from Hamilton County that take the SAT. We used a sample of size 220, and our confidence interval runs from 77.0% to 85.7%, and we want to work backwards to find the level of confidence. Well, the level of confidence is determined by that critical value, so we need to work backwards to find that. First, it would be helpful to find the statistic, the actual sample proportion that was used to build this confidence interval. So understand, the sample statistic is always smack dab in the middle of the interval. So from that statistic, we add the margin of error to get the upper boundary, and we subtract the margin of error to get the lower boundary. So here's our upper boundary, and here's the lower one. So literally, the statistic is exactly in the middle of our confidence interval. So what that means is, in this context, our sample proportion is simply the average of these two boundaries. If I find the middle of the 0.857 and the 0.770, so if I find the middle of those two, I will get my sample statistic, which was 0.8135. So the reason that that helps me is, notice from that sample statistic to get the upper boundary, I add the margin of error. So similarly, starting that statistic to get to the lower boundary, I subtract the margin of error. So if I find the distance between the upper boundary and that statistic, that gives me the margin of error. So the margin of error, in this context, all I have to do is take the 0.857 and subtract my statistic, the 0.8135. And that gives me the margin of error. That should be 4.35%, 0.0435. So we're almost there, because the margin of error is made up of two components, the critical value that I need to find and the standard deviation. So my margin of error is the 0.0435. That is made up of two parts. My critical value, which would be a z-score here because these are proportions, times the standard deviation of this statistic, the standard deviation from this statistic's sampling distribution, which we reviewed today. So to find that standard deviation, I would use my statistic, the 0.8135. That's my best guess at the truth. And I would take 1 minus that statistic, 1 minus the 0.8135. So it was convenient that we were told the sample size was 220, because I can divide by that 220. And that will give me the standard deviation that was used to find the margin of error. So if you simplify this, the standard deviation is about 0.0263 if we round it. So to find the critical value, all I have to take, I just have to take the 0.0435 and divide by the 0.0263. That will give me my critical value. So you end up with a critical value of about 1.65, which maybe you recognize this, maybe you don't, but that critical value tells you how many, it's a z-score. Z-scores tell you how many standard deviations above or below the mean you happen to be within this approximately normal distribution. So to find the level of confidence, I just have to figure out what percentage of approximately normally distributed data would be within 1.65 standard deviations of the mean. So when you're working with z-scores, we have a mean of 0 and a standard deviation of 1. Here's positive 1.65. Here's negative 1.65. So what I have to do is find approximately what percentage of normally distributed data will be within those two z-scores. And this is a classic example where you could use the normal CDF command. So our lower boundary is the negative 1.65. The upper boundary is positive 1.65. So that area is about 90%, 0.901. But then that tells me ultimately find the level of confidence. What that tells me is that the level of confidence that we are working with, this is a 90% confidence interval. That's what we've established here, that level of confidence. This is a 90% confidence interval. That's what we just determined. So in order to determine that, I know that there are lots of pieces here, but the idea is to use an example like this to explore the structure and the way that sampling distributions are combined with confidence intervals, the way that those two are related together. These are some of the most important calculations that you would have to do on the AP exam.